Hello again. I'm learning to code in Rust, and I'm going to do it live. Um, my students, when I was teaching C#, seemed to think that it was pretty cool that I was live coding C#, which I had a lot of practice in, by the way. So I thought, people might enjoy this too. So here we go. Last time I had, let me just switch this here. There we go. Last time I had done a little bit of work with the first two elements of, there we go, sorry. The last two elements of, there, this. We were doing Rust by example. I'd done formatted printing. We just did some stuff with debug printouts with the : option, and we did these activities where we fixed the code and we got Pi to display in the right way, and now we're moving on. So let's just click the arrow and see what comes next. Okay, debug. So let's see, all types. Which one to use? Standard format, format traits. Okay, what's this? We have some definitions here. All types which want to use standard formatting traits require an implementation to be printable. Okay, so again, this is like the C# toString business, except that C# toString has a default, so you don't actually have to override it if you don't want to. But here, it would appear that we actually have to do something. However, we didn't have to, last time, we didn't have to implement anything for debug. What we did have to do was we had to mark the structure or whatever the object was with this derived debug. And then that was sufficient. And that gave us the ability to output any object. So they've got some kind of generic dump any object to the output kind of thing for us, but we have to tag it that way in order to make that happen. So this one says cannot be printed with either format display or format debug. So like if it's just the struct, cannot print it, we need to stick this derive debug thing in front of it if we want to print it as a debug construct. But typically you don't actually want the debug, well, except for debugging, of course. But what you do want is you want some kind of fancier thing. So let's just have a look. What's this thing? So this is what we learned last time, which was : allows us to dump stuff out. So here we derive the structure with debug, drive debug the structure, drive debug deep the structure. And now deep the structure 7 will print, and all that good stuff will print. So cool, whatever. We did this last time. Okay, so again, it's printable, but sacrifices some elegance. So, pretty printing with pound ? All right, okay. Let's have a look at what pound ? will do. So let's pop over to the code and just make that one little tweak. So this one we were printing right, where was it? This one, this object here, structure value. So let's just output pound print. Let's see what that does. Save that. And then again, I need to figure out a better way of doing this than scrolling back and clicking run. Run. Okay. Okay, so this structure bracket line break 7 comma bracket won't print. Okay, so the prettier printing is to do some line breaks, because I think the original, what we had last time, and I can prove this. Let's just go back here and fix that. All right, without that, save that, and okay, I really do need to figure this running business out. So let's click on this, run and debug. Can we do that? Cannot start debugging because no launch configuration has been provided. Okay. Okay. Would you like to generate a launch configuration? Yes, I would. Okay. Add configuration. Whoop, no, no, no. I guess I don't want to actually add configuration. Because I think it's got it in here already. The thing we want. Maybe. Okay. So let's save this. And let's click on debug. Yeah, debug executable. Click run that. All right, did it run? All right, let's try. All right, so here. No, I don't think it did run. What are you doing to me? Oh, there, it's running now. I had to click the green arrow instead of the drop down. Okay, so what's this? Oh, what's this? Console is in commands, prefix expressions with what? Launched, process exited with code 0. Yeah, but, oh, that's the debug console. Terminal. Yeah, there it is. Structure 7. So it did run. What's weird is that when I click on this, it pops me over to the debug console, which, oh, I guess. No, and that went back to the terminal that time. All right, so in the debug console, we get that. The terminal, we get that. And this is actually running. Okay, I think we're good now. So and instead of scrolling back up, and I can close this now. And instead of scrolling back up and continuing to hit run over here, I could just click that guy and get the same behavior. Okay, cool. Anyway, the point was, with the hash, without the hash, we get this not so pretty, I guess, in theory. And let's put, can we do this? It's gonna let me do this. All right, let's try that. And, oh, I want to put the pound back in. And save that. And execute it. Oh yeah, this struct quotes. Yeah, there we go. Line break. Oh, good. So \n, in case you didn't know, is the line break character. And so I'm able to, so this struct line break backtick the structure 7 whatever backtick, and then space, which is why that doesn't line up. Space won't print ... So you can do this to get a little fancier if you'd like. But yeah, so there we go. So that's working. All right, let's pop back to the lesson then. Where'd you go? There you are, the browser. All right. So yeah, so there's some pretty printing going on. So if we have a more complex object like a person with a name and an age, whatever this is, which is unexplained, but okay, we can carry on. Cool, fine. End of lesson. Let's move on. All right, display. So format debug doesn't look clean, so we'd like to customize it. Yeah, generally speaking, if you're showing it something to the user, you don't want to show them crazy, coder stuff. You want to show them something, nice and formatted for users. So we probably want to do some kind of formatting. Okay, and so which uses the curly bracket, print marker, implementing it looks like this. All right, so what do we got here? Import via use, and then struct, and then format display. Okay, so here's some new syntax. So there is the use statement, which I guess is the similar thing to the C# using statement, and the import require statement in JavaScript, and whatever else. Everybody has a variation of this. Include, I guess, is kind of an old-fashioned standard way of doing it. So that marks this library, says we want to bring it in, and then we're going to do some kind of impl, which I assume is short for implementation. So it's saying, hey, we've got an implementation of format display for this structure. So that's the way I would read it. And then inside the curly brackets, then we have a function called format. So I guess to implement the format display, we at least have to implement a format function. And so then we've got some other interesting new terminology. There's self, and there's this mut thing, which I assume means mutable. We'll short form for mutable. We'll get to that, I guess, sometime. Yeah, sometime over here we'll get to something mutable, changeable. So if you've noticed, so far we've populated objects, but we've not actually tried to change an object in the code. But this, I guess, is telling us that, hey, we're going to be able to change this, mutate this formatter thing, this F that's of type a changeable formatter. And then I assume this arrow indicates that this is the return value. And then in curly brackets, we've got the code we want to execute. Okay, and then down here, we've got this write exclamation mark. So I believe exclamation mark is a macro, right? Exclamation mark. I don't know that they actually said that, but that's the impression I get, is that things with exclamation marks on the end are macros. Maybe I'm wrong. We'll find out. And then we're passing in f is taking 3 parameters, write is taking 3 parameters, and that's f, that formatting string that we typically use, and then self.0. Interesting. Okay. So this is for structure, right? So let's just copy. So now we have something. I'm just going to use, so I'm going to copy that. Let's pop over to there. And so we have a struct i32. I think the idea would be to do this above. I think this is where I would put it anyway, is I would put all my use statements up on top. And then I'm going to go back to there, and I'm going to grab the implementation chunk, and I'm going to put it here, outside, at the top. So back in the day, when I first started using C, there was an issue where you had to declare things in the right order because the compiler was not smart enough to recognize that you had defined something. So if you had a function you wanted to call, you needed to define the function first and then write code that would call the function. Now you could pre-declare some things up at the very top, but it was like extra work to do this. So kind of a typical pattern, a common pattern, was to write your code so that the main line is at the very bottom and all the support functions are on top. And the lowest level support functions are at the very top of the file, and then more and more, more and more levels until you finally got to main, which is the top level thing. And so that would what you would do if you wanted everything in one file. And if you didn't want everything in one file, then you could use include statements. Now includes were kind of fun because if you included the same file twice, then it would make 2 copies of everything inside that file. And then there were macros where you would check, hey, is this implemented or is this included already? And then anyway, it got really messy. And so we've mostly tidied that up, and it looks like everything is kind of self-contained inside this main RS. We haven't actually had 2 files yet, so we don't really know for sure. But I'm hoping that they tidied most of that up. So anyway, let's move on. So the explanatory code or comments I can live without. I don't need it to be quite that verbose here. And let me drop this down a little bit so we get more code and less not code. Okay, so what's going on here? So we're using that and we're implementing that with a function that takes self and a mutable formatter, returns a result, and we do this. Now, interestingly, there's no semicolon here. Now, that's kind of interesting. That is kind of fun. All right, now so let me just save this. And, structure, right. Oh, look at this. Cannot find structure in the scope because we defined it way down here. So let's take that and put it up here. Now I wonder, again, ordering matters, but I wonder whether ordering still matters. Ordering does not matter because structure is defined after it's used, but it's cool. Now, having done that, I'm not actually going to do that. All right, so allow dead code. That was there because we had some code commented out that was generating an error and whatever. So we don't need this allow dead code anymore. The derived debug we still need because we're printing it out by debug. So let me just take that and put it there. Because honestly, I think, you know, I like to group things, and I guess it's like, hey, here's the structure and here's all the implementations for structure. So define it first and then use it. So again, it's kind of my, you know, back in the old days, this is what you did. So it's kind of what I'm going to do. All right. So again, I don't 100% understand what's going on here, but I assume this arrow is like the fat arrow, the double arrow in JavaScript and in C#, where it effectively says this is a, you know, I'm going to define a function. Although this one seems to have a different meaning in that it's like this is my return value. So the arrow is pointing at the return value, which I'm guessing, because this, if I cover over that, write is a macro, and this says commonly a format result or an IO result. So it's going to return a result. So yeah, so write returns a result. So then this whole thing is going to return a result or error. See that? Comma error. So that implies we're going to either return something or an error. Okay, and then write returns a something. Now here's something interesting. See this? This write has a semicolon after it, and also a question mark after it. Okay, fun stuff. We need to figure out what that's all about. And what else? What else have we got here? Oh, here's an example. Form write, for example, write string, unimplemented. Okay, whatever. Right. Okay. So anyway, that's returning a result. This is returning a result or an error. I'm not sure how it figured that out. Like, we didn't actually say error, yet it's saying, or is it telling me that that's what it expects format to return when I implement format? No, I don't know. I'm a little puzzled by that error thing. I don't know where that's coming from. All right, I'm sure it'll tell us eventually. Okay, so let's take the opportunity to set a breakpoint here. And let's go down here, and we dumped this with the hash question mark business. And all right, we don't need the to do anymore. Delete. And we don't need this comment anymore. Oh, and we don't need that comment anymore. But we are going to do, actually, let me change this to will print, because it will. And we'll take this line and paste it below. And then we're going to change this to be just the curly brackets. Okay, and because we have an implementation of the display, it should actually print something. All right, actually, you know what? I'm going to take the breakpoint off temporarily. Let's save this, and we'll run this. We'll just see what comes back out. Okay. Oh, and there's make this a little bigger for now. Okay, so then, this struct won't print. I thought I changed it to will. Yeah, what's going on here? Did I scroll too far back? Oh, there's will print. Is this just, this is just will print. What happened? What happened? Where did all the text go? That's weird. There's no errors. Now, I moved struct out here from in here. I wonder if that changed. Structure. I wonder if the fact that two implementations. Derived debug, and then that. Okay, those are the two implementations it's talking about. Okay. So, I have the structure. I have the structure, but why did it not print anything else except will print? And only one of them, for that matter. But where did this struct go? Interesting. All right, let me just try that again. Oh, there we go. Well, that was weird. I took the hash away, and now they're there. This struct, structure 7, will print. This struct 7 will print. Okay, and so the difference between this one, and we won't worry about why the hash has caused this grief. We just won't. I don't want to figure that out right now. So this one is the first one causes that. The second one causes that. And so this one we knew from before that it was going to format for debug. So it's telling us the name of the object and its contents. This one is only telling us the contents. And why is that? Well, that is because that's what we defined here. Because we said self.0. So clearly self.0 is equal to 7. It's the first property of the structure, I guess. So if I set a breakpoint now, let's this time debug this again. And there we hit the breakpoint. And now let's see if that's the call stack. Oh, here. So self 0 is 7. I don't know what the double underscore business is, but it's the, I think that's self.0. I wonder, if we went to the debug console, can I type something here? Can I say self.0? Oh, self is not a valid command. Well, that's not, okay. I was kind of hoping that this would act like the console in the browser, where you could just go in and type stuff and it would execute for you immediately, but that doesn't seem to be the case. There's probably some way of doing that, but I'm sure it'll be introduced to us at a later point, but I'm not going to go hunting for it right now. But this is good enough, because I can see that element 0 is 7, and then F contains a bunch of things. It's an object, and so it's got flags, it's got fill with spaces, it's got alignment unknown, it's got a width and a precision and a buffer. Oh, okay, so this is a memory location, I assume. Yeah, it would appear to be some kind of, I wonder what that means. 8 and 16. Interesting. Anyway, so yeah, there's a V table, some kind of virtual table, some kind of pointer calculation going on, pointer into memory, I would assume. And maybe this is telling me the location, the length, but it's an int 32, so it should be 32 well, not necessarily, because if this is in bytes, yeah, I don't know. That maybe there's a minimum. There's probably a minimum size you can allocate, because you don't want to allocate things that are too small. Because if you allocate a 4-byte block of memory, it's got ugly. Typically, because then your addressing needs to be like on a byte boundary addressing, and you don't really want to do that usually in memory allocations. You typically want to, excuse me, you typically want to chunk the memory into larger chunks. And so usually what I've seen in the past is 16 bytes is the smallest chunk that you'll allocate virtually, in memory. Now, that's not to say, I mean, if assume that's in memory, but it could be on the stack too, but unclear how I'm going to figure that out. But again, I'm sure we'll figure that out later. What's registers? What is registers? Oh, okay. We have general purpose registers. I assume that an int 32. Okay. We don't have. Yeah. Oh well. I don't think we're gonna debug with registers anytime soon. All right. So anyway, little adventure over here on the side. Let's see. Okay, so we set the breakpoint, self.0. If I hover over it, it tells me it's 7. I can also, again, look over here and see what it was. F is that object, and I can see what that is by hovering over it. And yeah, so there we go. And so when I continue that one, it's done. Okay, so now, again, I pointed out a couple of weird things. So this is returning a result, and it looks like it's working properly. If I change this to self.1, what's going to happen? Is it going to complain at... No, it's going to complain at compile time. So, sorry, there is no field 1. Okay, so I can't artificially create an error. Darn. Okay. Well, that's actually handy. The compiler is going to help us out here. Um, all right, let's put a semicolon in here because I mean, you know, every other statement ends in a semicolon. Why isn't that one ending a semicolon? So let's try that. Oh, now we're getting an error. It says the type returned by formatter methods. Okay, and we're getting an error. Why? Where's the error? Oh, mismatch. Here we go. Here's the error. Implicitly returns brackets as its body has no tail or return expression. Remove this semicolon. Oh, okay. So let's see. But what if I did this? Because, oh, it's happy with that. That's what I thought. I was kind of thinking that that's what's going on here. So what it's doing is the last statement in the function. If the last statement in the function returns what the function should return, then you don't need to specify return something, which, you know, typically in JavaScript or in C# or whatever you would see, you would do this. But idiomatic Rust appears to be to do that, which is to say, hey, by not putting a semicolon here, I am telling you that you want to write I'm telling you that you want to the return value from write is the return value for the whole function. So actually, let me just put that back again. So I know a compiler compiled, but let's just make sure that it actually runs if I do this way. So again, run. And, oh, right, we hit the breakpoint. Continue. And that worked. Right, there's the 7 again. Okay. So we can either do this, which again is more comfortable for people with familiarity with other languages, but hey, you know what? I'm going to write idiomatic. I'm not going to try to force my old fuddy-duddy C, C# JavaScript ways on this fun new Rust language. So, all right. So now the question is, so what if I want to write two things? So write f curly bracket, in quotes, curly brackets, and then self.0. I'm going to do it again. So what I should end up with is, okay, can I do that? No, I can't do that. It's going to say syntax error, expected semicolon. Oh, okay, so that one needs a semicolon because it's not the last one. But this one does not need a semicolon because it is the last one. Well, that's interesting. Okay, let's save that. Oh, what's this? We got a yellow thing now. Writes formatted data into buffer. This macro, oh, but that's not, that's examples, but where's the error? Way down here. Here we go, at the very bottom. Unused result that must be used. All right. No quick fixes available, so it's not going to give me any ideas. View problem. I wonder, because remember when we were looking at the code in the example, which was over here. Not this one, but the previous one, I think. Here. Where'd it go? Where'd it go? Where'd it go? No, not there. Where did I see it? Where did I see it? I could have sworn earlier today I said, hey, what are those question marks at the end of the lines? And where did I see that? Huh. I can't find it now. I could have sworn it was right here, but maybe it must be in somewhere that we did. Nope, not here. Alright, can't find it. But I know we saw it because I remember commenting about it. But I'm thinking that because, I mean, and those were in a formatter where it was outputting multiple lines of stuff. Where did that go? Where did that go? Damn it. Oh, you know what? It was in a help. It was in help. That's where it was. That's where I saw it. It was in the help. Let's go back to there. And let's go here to look at the example. Well, that's not very helpful. Was it in here? Huh. Was it in right? Oh, yeah, here it was. It was in right. Here it was. See? It went right, exclamation mark, question mark, semicolon, right, exclamation mark, question, semicolon, and then the final thing. So I wonder if the question mark will solve my problem here. And it does. I'm not sure why it solved the problem, but what's it say? Use in question mark to decide whether the operator should produce a value or propagate a value back to the caller because it returned a control flow break. Oh, and that was, it referred to something about it when I had it missing. It was saying there was some kind of, hey, it was saying, hey, this potentially had returned an error and you need to handle the error, right? Unused result that may be an error. So I'm guessing that what this is doing is it's saying if the first write returns an error, then don't go ahead and do the second write, just exit the application. So it's kind of like an exception handler. So, you know, because in C# you would write try catch, or JavaScript, or actually C# and JavaScript you would write try catch blocks. And you would say, you know, try, and then all of these things. And if any of them threw an exception, then it would go to the catch block and potentially the finally block, and then out. This seems a little different because I'm assuming what's happening is that it says, hey, the caller seems to be responsible for dealing with the error. So the only thing we do down here is propagate the error forward, and then somebody else is in charge of dealing with the error. And because we're implementing a format display, presumably it means that the print line, this print line function, is responsible for dealing with any errors. Now, interestingly, we don't put a question mark at the end of here because this print line, it would appear, panics if that happens. But why? Okay, so you're telling me that if standard out fails, then it's going to panic. I guess, because I interpreted that as an exception. But there's something else called an error, which is not an exception. It's a different style of exception. So maybe there's like two forms of exception here. And interesting. Okay. So now if I run this, all right, and we hit the breakpoint. Let me just take that breakpoint away. I don't need that anymore. So continue. And we're 77, right? And it makes sense, 77, because we wrote 7 and then we wrote 7 again. And notice that this is right. So it's not right, it's right. So there's no line breaks automatically inserted. So whereas print line will insert a line break. So I wonder if there's a right ln. Yeah, there's a right line. Okay, so if I run this one instead, what happens? Go. Oh yeah, there it is. So 7, 7, line break, and then the closing quote. So we can do either a right or a right line. Typically, I think what you'd want to do, unless it was you really wanted to do a multi-line thing, you were dumping out some kind of multi-line message, that you would typically do everything with rights and then let the print decide whether there should be a line break afterwards or not, because you're using this inside of a string, and so there may be other parts of the string that you might want the user to have, or the caller to have, more control over. If you stick the line break in here, then the caller is not going to be able to control what they want in terms of format as nicely. So, I mean, there are special circumstances, obviously, but this is fine. Okay, so we got something. We got this question mark thing. We have with F, and presumably, I don't know what happened here, why this had to be. This is self thing. So self, and it's not just self, but it's ampersand self. So in C, if they're following C patterns, then ampersand was address of. So are we passing the address of self? And then self dot 0 would be an operator that would point to. So do we have a pointer here? I don't know. I'm not sure what that means yet, but we'll find out. But there's some questions still here. So ampersand self, I don't know. By the way, okay. All right, let's move on. Let's see, what do we got here? Back to. Oh, I did it again. All right. So test. Oh, did we go too far? Display. Display. Blah blah blah. Activity. Oh yeah. Oh, there's more. So we did this part. Now let's look a little further down. Okay. So format display may be cleaner, but this presents a problem for the standard library. How should ambiguous types be displayed? If the standard library implement a single style for all vector, what style should it be? Right? Yeah, whatever. Okay. So, okay, yeah. So what they're justifying their laziness and going, hey, listen, we don't know what you want to do with complicated objects, so we're going to make you do the work. So simple data types, strings, ints, floats, those sorts of things. They've created some standard formatting, which we've taken advantage of in the original printout stuff. But when it comes to something more complex, and basically anything is more complex than the simple data types, then we're going to require, or Rust is going to require that we, you and me, do the work. All right, so let's see. So min-max. Debug will be derived so the results can be contrasted with display. Okay. So this is a big one. So let's create a new project. Where are you? There you are. Okay, in terminal, we're going to say up here we're going to do it. Create or crate new print vector. Is that right? Yeah, I think that's what we're doing. Or print complex. So we've been printing simple. Now we're going to print complex. Okay. Did I do that right? Terminate. Oh. Did I not remember? Okay, let me try this. Up arrow. Cargo, not crate. Crate and barrel. Cargo. Okay, yeah. So I need to start with a C. Cargo. Okay. Now we're going to file. Close folder. File. Open folder. Where'd you go? Oh, did I not pin that? Shoot. I have to go drilling around here. That's annoying. I'm going to pin that next time. So it's in C drive Rust. Okay, there we go. So there's print complex. So I'm going to select that one. Select folder. Okay, and we're back in business. We've got a new project with a new main and a new cargo and new targets and all that good stuff. All right, and by the way, I'm going to see if I go into debug. I've got to do it again. Okay, yes. So create a launch configuration, close that. Okay, now run. And terminal, hello world. Yes, okay, good, cool, that works. So that's not a global setting, unfortunately. It's a project setting, so I'm going to have to do it every time I create a new project. Sad but true. Okay, now back to the business at hand. Let's copy this and actually, you know what? Control A, Control V. There, done. All right, so we have our import format. We've got drive debug. We've got this min-max thing. We've got a format display for min-max where we're going to, oh, and look, self.0, self.1. So this is 0, this is 1, I assume. And then we've got a 2D pointer object, and we're going to label X and Y this time, and it's going to be, oh, that's interesting. So we can say it's, so here we had self.0, self.1 because it was element 0, element 1. Here we've got self.x and self.y because we actually gave them names, x and y. Okay. Oh, and by the way, the other interesting thing is in terms of structures, there's an interesting style thing going on. Because in C#, you would capitalize the structure and you would capitalize all the public properties. Now, it would appear that X and Y are public properties because I can reference them here publicly. So, and in C#, they would have been, because there was no decorator on them, they would have been decided to be private by default and then public when you say it. I'm wondering whether that's going to be something that we're going to discover in here when we get more deeply into structures. Maybe not. I don't know if structure, you can attach code to structures. I mean, you can create this implementations for the structure. So maybe you do that way. You can't actually put code inside, but you can declare functions inside the structure, but you can create implementations, maybe. Anyway, interesting. We'll have more questions. But anyway, but I was going to say capitalized, and in JavaScript you would do lowercase p, lowercase x, lowercase y. So everything would be lowercase. That's JavaScript. C#, everything's uppercase. And here we've got this interesting combination of uppercase structure name, lowercase elements or properties of the structure, or fields of the structure. I'm not sure what the terminology is that would be appropriate here. All right, so self.x, self.y. And we've got min-max. Ooh. All right, so here's another thing. Typically, C-spell is going to complain about words like this. And it would appear to me that, see how we have big range, underscore range, small underscore range? It seems to me, although, again, we've got some weird stuff going on here because we're using snake case for variable names, but then we're using uppercase, mixed case, Pascal case is what it's called, for the objects, like that's a Pascal case thing. But then on top of that, this should have been min underscore max if we're going to follow the pattern here. So let's see if I can do that. Here, view quick fix. Admin max the dictionary. I don't have the ability to edit? Come on. All right. Let's not do quick fix then. Let's see, view problem. Can I do it that way? Unknown word, yes. You're not going to let me change it? Okay. Let's see. Is the rename function going to work? Oh, cancel that. Is there a rename? Right click. Refactor. Nope. Rewrite. No, that's so in Visual Studio it would be refactor rename. Oh, but here it is. Rename symbol F2. I don't remember that. And then let me just go min underscore max. There, changed everybody to min underscore max. And that is more correct. So, hey guys who wrote the tutorial, what is the convention? Because you've got all sorts of conventions going on here. So I'm curious to know what the actual convention is in Rust. Anyway, so I tidied that up, got my spelling checker to fix my error. And then, okay, so let's just run this then. So save this. We will run it. And okay, so we have compare structures, display 014, debug min-max 014. The big range is -300, 300, and the small range is 3, compare points, display that, debug, point do to boom. There we go. Okay, so the display is our formatting. The debug is always going to give you the name of the thing, curly brackets around name value pairs inside the thing, that are inside the thing. One thing I'm curious about though is because I'm able to use self.x, self.y, I wonder if I can use square bracket syntax here. Well, all right, save that. Nope. Cannot index into a value of type ampersand min max. Okay. What if I said, because this used to work in C. Nope. No. And is there, and in the other, oops. Let's put it back. The other thing in C was this, although that's unlikely to work. Yeah, what's this going to say? Expected. Oh, what are the expected characters? Exclamation mark, comma, decimal, double colon, question mark, curly brackets, or an operator found. Expected one of several possible tokens. Okay. All right, now you've got me curious. Self exclamation mark 0? What does that do? Ooh. Expected one of, oh, square bracket. Nope, that wasn't it. Cannot find macro self. Oh, the exclamation mark meant macro. Okay. All right. Right. Yeah. So so there we go. So that answers my question from earlier. It says yes. Exclamation mark means macro. So we'll, okay. Enough playing around for now. We'll just all right. Function self creates own data from borrowed data, usually by cloning. All right. I don't know. All right. Interesting. Examples. All right. Well, whatever. Good enough. We'll stop the adventuring for now. So, okay. So this is running. Let's see. Let's go back to the this and see if there's anything they want us to do. Activity. Yeah, there's an activity here. Okay. So yeah, I mean, there's nothing too crazy going on here, right? We're just like structure was a thing with one parameter. This is min-max has 2 parameters. This thing has 2 named, 2 properties. This has 2 named properties or fields. Oh, they're using the word fields. Okay. This has 2 fields, unnamed fields. This has 2 named fields. And we've created a display for each of them where we do some writing. We reference either by .0.1 or by the names x and y. I assume the names are 0 and 1 because this is 0, this is 1. And so, you know, if there was more, you'd be able to reference it by 2, 3, 4. But it looks like, all right, one last all right, one last experiment. This is a number, right? Can I put a variable there instead? So if I say let x equals 0, can I say x? Oops. Delete. Save that. I cannot. So, right, no field x on mat. Yeah, okay. So no, it's not interpreting it like a number. It's interpreting it as a name, an unnamed name. So yeah, so we're stuck with 0, 1, 2, and you can't loop over things. Because I was thinking if I could put a variable there, then I could loop. And I could just iterate over all of the self dot whatevers. But it doesn't appear I can do that. Now, so, okay, all right, fine. Syntax is the syntax. Okay, so that's, sorry, I got carried away there and I wanted to try that thing. All right, let's back to here. All right, okay, activity. Let's do the activity and then we'll call it a day. After checking the output of the above example, use point2d struct as a guide to add a complex struct to the example. When printed in the same way, the output should be display blah blah blah, debug complex real imagined. Okay. Piece o' cake, right? All right, so whoops, let's do that. So right, so we're going to borrow this, right? Because we're just going to take this, or nah. Well, let's borrow this one because I guess we should have them be named, right? Because that first one is unnamed, and this second one is named. And I guess what we probably want to do is we want to do the real and the imaginary part. So we want to be able to specify which one's the real and which one's the imaginary. So we'll take this and paste it here, and we're going to get an error because there's two definitions of point2d. We should get an error. Yeah, there we go. Well, why are you complaining about debug though? Oh, okay, because you're implementing debug twice on point2d. Okay, well, I'll solve that problem for you. Struct complex, and we'll call this real and imaginary. And we'll go for complex and save that so the errors go away. And we're formatting this, and we want to do let's go back and see what he wanted. What did he want? Oh, come on. He wanted real You know what? Forget it. I'm not going to do real imag. I'm not going to do that. R and I is sufficient. So, but he wants a comma here. Which I think it'll do, right? Yeah, I think it'll do that. I think it'll do that for us. So it's like 3.3 or whatever plus whatever I. Okay. So what we want then is to have the real part space plus the imaginary part I. And then this will be self.r. Self.r. I keep hitting enter instead of delete on this keyboard. Self.i. Save. No semicolon because it's the last one. We can get rid of this line because it's wrong now. And we can get rid of that one. Okay, so there we go. And now so we need to implement a format binary. That's interesting. Okay. All right, we'll get to that in a second. So it's we need to do let C equals complex 3.3 or 1.7 arrow over semicolon. And let me see if I save this. Oh, yeah, there we go. The format happened. Why are you complaining? All right, what did I do wrong? Oh, round brackets, curly brackets. Duh. Sorry. All right. save that. Why are you complaining now? Missing structure fields. R. So, yeah, I forgot. I didn't give them names. There, now it's happy. Okay, so we got complex is that, and that yellow one is going to be, hey, you're not using this. Yeah, unused variable. Trust me, we'll get to it. Print line, go away. That was an escape key to make that go away, by the way. Display, curly brackets, comma, C, print line, debug, colon, curly brackets, with a colon question mark, comma, C. All right, let's give her a run, see what happens. And here we go, display X. What? What? There's a plus sign here. How did you get the X and Y? Oh, this is the points. Why we didn't run. So this didn't get executed. Well, that's weird. What's going on here? So, hang on. It's stuck. Console is in commands mode, prefix expressions with. Alright. Looks like I am stuck. So it's not actually running. Let's kill this. And then oh dear. Okay. Nope. That's not what I wanted to do. I kill it. I kill it, Dad. Help me out here. Control C. In terminal. Control C. Debug console. Quit. Exit. No, that's not doing it. Alright. You are stuck. Well, there's another way of solving this. Kill that one. No, that didn't do it either. Alright, how about we kill the whole thing? That should solve it. When in doubt, turn it on and then turn it back on again. Alright, so let's figure out what, if we run it again, will it work? Terminal. Oh yeah, there it worked. So there's 3.3, 1.7, and then complex in debug. So yeah, it's working the way we want it to work. So you know, turn it off, turn it on again, and see if that solves your problem. You know, tried and true. And finally, this thing about format binary needs to be implemented. So if we did this, what's going to happen? What does that look like in binary? So, we have an error point. What's this? Point binary is not satisfied. Okay. So, should we implement binary? Or is that on its way? Well, I wonder. Well, what the hell? Let's give it a try. So, and it's for this one, right? So I can say impl format binary for 0.222 D. And fnt, fmt, and self, F colon, and mut, fmt, formatter, returns result, and in here we're just going to write F and then X colon curly brackets colon B, Y colon curly brackets colon B. Why isn't it highlighting it the right way? What did I miss? Oh. Exclamation mark. That still didn't do it. Comma. Self.x, self.y. Right. But this is, I'm doing something wrong. Oh, double colon. There we go. There. Now everything's highlighted properly. Okay, so now, there. Save. 2 errors. Oh, because what? F64. Oh, because F64 doesn't have a binary implementation. Okay. Dot to string. Dot to string. I wonder if string. Oh, okay. Whoop. Oh, that's C#. What's your problem? Nope. Okay. Or is there a way to do to integer? To int unchecked. Unsafe. Are you going to let me do that? No, still not going to do that. Float to int. Float to int. How about that? Oops. Right. Oh, with any luck, that works. Save that. Nope, that doesn't work. Float to int. Is it a macro, maybe? No, there's no macro float to int. Okay, I don't know. I don't know how to convert floats to int yet in this language. So we can't actually do it. Okay, because float doesn't have a binary representation. But if we had an integer, presumably if we had an int, if this was I64, then I wouldn't need to do this float to int nonsense because it would already be an int. Oh, come on. Will it rescue me from this ugly, ugly formatting job? Yes, it did. Thank you very much. Okay. Oh, 2 errors. What's the errors now? Oh, there's probably, yeah, here. 3 and 7 instead of 3.3 and 7.2 because they're in integers now. And so let's run that. Okay, yeah, 3 and 7. Yeah, 0, 0, 1, 1. So that's, 1 plus 2, and this is 1 plus 2 plus 4, 7. So yes, that is the correct answer for those. All right, so what do we got next? Next time, I think I'm going to stop here, but I just want to have a peek. Oh, that's the problem. All right, so next time, we're going to do more formatting, but we're going to do it with a list. Yeah, so more formatter stuff with a vector and iterators and stuff like that. Okay, so some interesting things we can look at. All right, then that's it. Thanks for watching. I'll see you again.